Welcome back, everybody, to the Cisco lab. In this lab session, we're going to be doing configuring multi-area OSPF version 2. So let's go ahead and start the activity. So we do have an addressing table for us in the beginning of the exercise. It just basically tells us what are the IP addresses that have been configured on the device's interfaces. So let's go ahead. It also tells us which areas we have in the current design. So if you do remember what we discussed in our last scaling lecture, we talked about the areas, the different areas that we have in OSPF. We talked about the function of area 0, which is known as the backbone area. So in this design here, as we can clearly see, area 0 is the transit area, and that is because all the information needs to pass through area 0, otherwise the different areas will not be able to advertise different networks, and that is the main purpose of area 0 in this design. When we do have such a design where all the areas, the other areas which are not 0, are somehow linked to area 0 because the router also has an interface in area 0, in such a design, we call the design a contiguous design in terms of OSPF hierarchy. All right, so let's go ahead. This is going to be a pretty straightforward activity. So we're going to advertise the networks within area 1, advertise the networks within area 0, advertise the networks within the area 2, and then we'll see what happens, especially to the routing table. What are the entries in the routing table after we configure OSPF multi-area? So let's go ahead and read the background scenario. So in this activity, we will configure multi-area OSPF version 2. The network is already connected and the interfaces are configured with IPv4 addressing. It's our job to enable multi-area OSPF version 2, verify the connectivity, and examine the operation of the multi-area OSPF version 2. So let's go ahead and do the first part, which is configuring the OSPF version 2. So what we're going to do is we're going to go into router 1 and configure OSPF version 2 on router 1. The process ID as well as the router ID is given to us. So the router ID assigned to this specific router, router 1, has to be 1.1.1. Okay, so let's get started and do this implementation of OSPF within router 1. So I'm going to click on my router 1 CLI, and we're going to start doing this together. Okay. So the first thing to do is go into privilege exec, go into global configuration mode, and then we can start configuring routing. Is there anyone here that remembers the command to start configuring OSPF version 2? So all the dynamic routing protocols available in our routers, they are under the command router. Okay. So as we can clearly see here, the options we have in the router command include BGP, EIGRP, OSPF, and RIP. So for this specific exercise, we're configuring OSPF version 2. So we're going to go with OSPF. Now, right after the OSPF routing protocol, we also have to specify the process ID. Now, the process ID that we have to specify here is also given. The options we have for the process ID go from 1 all the way to 65,535. We're just going to go with the number 1. It's also instructed to us to use number 1. Please do remember and be aware that this process ID is locally significant for the router. So it's pretty much not going to be advertised to any of the other routers. It's just for us to keep track of the different OSPF instances that we are running in the local router. So we're going to choose number 1 here. And now we are ready to start configuring OSPF. Now we are within the OSPF configuration mode, as we can clearly see here from the prompt. And then the first thing we need to do is configure the router ID. Pretty simple command. anybody remember what's the command for the router ID? Very straightforward, router ID, and then followed by the router ID in an IP address format. Please do remember that the router ID has nothing to do with an IPv4 address. It's not going to be reachable or anything like that. The router ID is just to identify the routers, the different routers that will become adjacent in the OSPF protocol. So for the router ID of router 1, we have to specify the all ones. It's going to be 1.1.1.1. Enter. And that's all we need to specify the router ID. All right. So right after configuring router OSPF, we also need to advertise the networks. And advertising the networks is just basically selecting the networks that we want to share with the neighbors. That's all that we are going to do. So as instructed by the activity, we are going to advertise all the interfaces of router 1. So that include all the 3 interfaces that are directly connected to router 1. Now, if I go back just a little and do an exit and do show IP interface brief, we're going to be able to see all the interface IP addresses configured on router 1. So we do have interfaces gig00, gig01, and serial 000 with IP addresses configured. So what we're basically doing here is we are advertising all of these networks into different areas. As we can clearly see from the design, all the gigabit interfaces, they are within area 1, and the serial interface is within area 0. We're going to do just that. So we're going to go and advertise the networks in the appropriate area. So we're going to go router OSPF1 that we just created. I don't need to assign the router ID again because it's been already assigned. And then we're going to advertise the networks. The first is the 10.1.1 with the wildcard mask 0.0.0.255. Remember, the wildcard mask is just the inverse of the subnet mask. So this one is a gigabit interface and belongs to area 1. So we're going to advertise this one. We are going to advertise the other one, the 10.1.2.0. Interrupted. So the wildcard mask is the same, and the area is still area 1. And also we are going to advertise the serial interface using area 0. 192, 168, 10.0. Wildcard mask, oops, interrupted again by adjacency. So let's go ahead. We were doing the 192. So we're going to advertise the 192, 168.10.0. Wildcard mask is 00.3 and area 0. Oops, I have to be in router OSPF1. Okay, done. So we pretty much advertise all the networks. If we want to see all the networks that are being advertised, we can just simply type it into show IP protocols. And we're going to be able to see that OSPF is currently running as the routing protocol of choice. We're going to be able to see the router ID that we have just configured. We're also going to be able to see all the networks that are being advertised by router 1. And the different areas as well that the networks are being advertised in. Right? So pretty much done with router 1. Now it's just a matter of configuring router 2 and router 3. So we're basically going to repeat the steps that we took for router 1 and just apply these settings to router 2 and router 3. And then we're going to see what happens. And we are going to discuss what happens. So let's go ahead and do just that. Now, before I do that, I'm going to give you guys 2-3 minutes to try to do it yourselves. And then I'm going to do it with you guys. All right. So I'm just gonna pause the recording a little bit. So if you're watching this activity, please make sure you pause and try to do it yourself. Okay,
I
guys. So
just
let's
check
go ahead.
like IP protocols, like
Mm-hmm.
do so,
So let's
but
go.
there are like in router one, but I can see like there is a gateway like 4.4.4 and 5.5.5 and 9.9.9.
Mm-hmm.
Like those are the ones that we didn't configure. Are those the one which are like
Yeah.
grayed
So
out?
those
Yeah.
ones are the ones inside the area. So you see that
Okay.
there's a cloud with all the routers inside of the area.
Mm-hmm.
So these advertisings, they are coming from within the area. Now let's configure router 2 and 3, and then we can talk about the results.
Yes, sure.
So let's go to router 2, CLI, same thing here. Enable conft router OSPF1, same process ID. I don't usually like to change the process ID, even though you could, as long as they're in the same area. I like to keep it a little bit consistent, so I always like to assign the same one. We're going to go router OSPF1. Router ID is going to be 2.2.2.2 for router 2, I believe. Yeah. So we have, yeah. So router ID for router 2 has been configured, and now it's a matter of advertising the networks in router 2. So we have to advertise the ones we want to form adjacencies. So we're going to have to advertise the serial networks and also the ones connected to router 2. So we're going to advertise all of these 3 networks. Let's get started with the first one, which is the ones, all the ones that are serial interfaces. Network 192.168.10 for the first one. And these are all /30 because they are point-to-point connections. So we do have 0.0.0. For the wildcard mask of a /30, I think most of you guys already know that it is 3. Okay, because the subnet mask is 255, 255, 255, 252. So please remember that when you add up the subnet mask and the wildcard mask, the result should be the all 255s. If it's not, there's something wrong with your wildcard mask. So this is going to be area 0. We do have another network, and now we're getting the adjacencies. Now, sometimes we don't want to be, seeing the messages and being interrupted by the messages when we are typing commands. There's actually a way that we can avoid that. I'm going to teach you guys how to do that because this might be inconvenient sometimes. So let's do that. So if we go to the line console and if we type it in no login console, these messages are no longer going to pop up in the console. So they will not be interrupting us when we are typing the commands. Okay, so this might be a good thing if you don't like to be interrupted by the log messages. So you can do a no logging console. If you do want the messages to still be shown, you can also use the logging synchronous, but the log messages will not interrupt when you're typing the command. Okay, they will be shown, but they will not be interrupting you when you're typing the command. So these 2 options, no logging console, logging synchronous, they will help us avoid being interrupted by these log messages. All right, so let's get back and finish advertising the other networks. Our OSPF1. So we already advertised the 10. Now let's advertise the 10.4. Wildcard mask is still the same, so area is still 0. And we are pretty much done. Now we just have one more network to advertise in area 0, which is the 10.2.1.0. That is going to be a /24, which in wildcard mask notation is 0.0.0.255. Also area 0. And now we are done. So you see that when I'm now advertising the commands, I'm not being interrupted by the log messages. There you go. Now we can verify that we have the adjacency. So if you guys remember what we discussed last week, there is a command to check the neighbors. Does anybody remember? Show IP OSPF neighbors. So if I do show IP OSPF neighbors, we'll be able to see all the neighbors that we currently have in the design. Now, we don't have router 3 yet because we still need to configure router 3. Right after we finish configuring router 3 will be a neighbor on router 2 as well. So let's go ahead and check the routing table to see if something has changed.
Robert, what is this DR after that state means?
Yeah, so this is about the election process. So you remember we talked about the election, who's designated router, who is not designated. So when it doesn't have this information, that is because it doesn't need to have an election because it's a point-to-point. You just have two routers. Okay? It's a point-to-point connection. It's a /30. It doesn't need to have an election. So here we have an election because we have many routers that are connected here in the gigabit interface of router 2. And it's telling us that router 2, the O4s, which is probably a router inside this area 0, is the designated router. Okay. Now let's go to router 3 and finish configuring router 3. So CLI. Now in router 2, I did the no logging console. For router 3, I'm going to do the logging synchronous just for you guys to see what's the difference. I'm going to go into the console and I'm going to type it in logging synchronous. And you see the difference. All right. And now we can start configuring router OSPF. So router OSPF 1. Again, router ID for this router is the all 3s. And that's all we need to initiate router OSPF process. Now we're going to advertise the networks in router 3. Let's begin with all the ones in area 2. Network 192.168.20.000.255 area 2. Okay. The other one is network 192.168.10. Wildcard mask is the same, /24. And you see that now it didn't interrupt me. I received a log message, but it didn't interrupt me. I can still keep typing. So did you see the difference? This is awesome. I hate when I'm being interrupted and when the log message just cuts my command right when I'm typing it. Just so inconvenient. So let's go ahead. So this one is area number 2. All right. And now we're going to advertise the serial network so that we can become adjacent to router 2. Network, you see, didn't interrupt me again. This is awesome. Okay, so I really love the logging synchronous. You guys should really start typing in the logging synchronous if you don't like to be interrupted when you're typing the command. Okay, so network 192.168.10.4 and the wildcard mask, which is 0003. And now this is in area 0. Now we're going to go back. Now we're going to return to router 2. And verify the neighbors again. And as we can clearly see here now, we are now neighbors with router 3 as well. Okay, so we do have a neighbor here, and a neighbor inside of area 0. Cool, we're pretty much done. Now let's check the routing table on every single one of the devices, and let's make comments on the routing table on every single one of them. I'm going to click on my router 1, enable conf d, I'm going to do show IP route. And we'll be able to see that we have O code routes that are learned and OIA routes that are learned as well. Does anybody remember the difference between these O and OI routes? Anyone wants to give it a go? Yep. So the IA stands for inter area. So that basically means they are coming from a different area. Okay, so they come from a different area. So if we check these two routes here, 192.168, 10 and 20 from R1 perspective, they are not in area 1, they are not in area 0. So they are coming from an area that router 1 is not even advertising anything. So it's being injected through the transit area, which is area 0. So all the networks in area 2, they are going through the transit area, which is area 0, and then they are going to R1 as inter area. So if you remember, international comes from outside, so it comes from outside of the area. Now we do have O routes as well, which are from the areas that the router participates. So basically this one, the 10.2.1.0, is actually coming from router 2. And because router 1 is actually participating in area 0, it is learned using just the standard O. Okay? Intra area, inside, okay? And inter area, outside, from outside of the area that the router is not connected to. Okay, is that clear? Now, in terms of administrative distance, nothing changes. Administrative distance is the same. Doesn't matter if it's the same area or it doesn't matter if it's inter area. The administrative distance is the exact same. Does anyone remember what this is? Right next to the administrative distance is the metric. Okay. Because it's OSPF, the metric is cost. So it's just basically the same thing. All right, so we are done. Now let's do the show IP OSPF neighbors on router 1 just to see the neighbors that we have. And we do have a few neighbors in router 1. Okay. Now let's check the routing table on R2 and see what we will be able to see. CLI. Do show IP route. We do have OIA only, so that basically means all the current routes being learned via OSPF in area 0, they're all coming from outside of the area, because if we have a look at router 2 only belongs to area 0. All right? Router 2 doesn't belong to different areas. So all the interfaces, all the networks being advertised in router 2, they belong to area 0. And currently, all the other networks that are learned, they are inter-area OSPF. Pretty cool, isn't it? Now, one more thing we need to comment on is the database, the OSPF database. So we're going to have a look at the OSPF database in router 2 first. So do show IP OSPF database. Oops. And we'll be able to see that in the database, we have the link state advertisements, the LSAs that we talked about last week. Okay. So we basically have the LSAs within the same area. So basically router 2 is sending LSAs type 1 because the LSA type 1s, they are about the area. We do have LSA type 2s because we have designated routers inside of the area. So on the clouds that are attached to the router, we do have designated routers. So we also have LSA type 2s. We also have LSA, other LSA types as well, received from the other routers that are also participating in a different area. These are all the LSAs that are shown. As we can clearly see here, all the LSAs in router 2, they are all area 0 LSAs because router 2 only belongs to area 0. Now let's go to router 2 and router 3 and discuss the database on router 2 and 3. I'm going to go router 1, sorry. Do show IP OSPF database as well. And we'll see what happens here. Now we do have something different. So we have area 0. So we have a database for area 0. And we do have another database for area 1 because now router 1 belongs to 2 different areas, area 1 and area 0. Okay. Now if we do the same thing on router 3, sorry, we're going to be able to see the same thing. So do show IP OSPF database. Going to show us that the databases of router 3, they are based on area 0 because router 3 is connected to area 0 and also router area 2, sorry. Okay. So we do have the link state advertisements in router 2 as well. All right, cool. So we're pretty much done with this exercise. We already discussed the commands. We already discussed how to verify the configuration. Now, just before we finish, I want you guys to tell me how many ABRs do we have in this design? How many area border routers we have? Anyone? Yes, we do have 2, so we have to remember the definition of an area border router. It's just basically a router that is advertising OSPF networks in different areas. Okay, so we do have router 1 and router 3, which are both ABRs. Do we have any ASBR? Any ASBR? Autonomous System Border Router? Do we have any? No, we don't. So remember that the ASBR is for external networks. Currently, we don't have any. All right. There's no other connections outside of these OSPF domains.